Hi and welcome to Logarithmic Differentiation. You're going to have fun in this video. I'm going to show you how to execute a differentiation technique. It's called Logarithmic Differentiation, and you use this technique when there is a variable in the exponent and also in the base of a function. For problems like these, you cannot use the power rule or derivative rules for exponentials because the variables are in both places. So the first thing you've got to do is get the variable out of the exponent. And the way we do that in most cases is by taking the natural log of each side. So if I take the natural log of y and I take the natural log of x to the natural log of x, using properties of logarithms, I can now bring this down out in front. So the natural log of y is equal to the natural log of x times the natural log of x. Now at this point, the next step is to take differentiation, but you have two options. You can here use the product rule, or you can rewrite this in the form of the natural log of y equals the natural log of x quantity squared, and from here you can use the chain rule. So I'm going to show you the chain rule technique first on this one because it's a little bit easier and I like it a little bit better. At this point you take the derivative of each side. So the derivative of the left side is going to be 1 over y times dy dx. You need this here, that's part of the chain rule. And on this side you've got to use the power rule first. So you've got 2 times this thing to the first power, and that thing is the natural log of x, and then you have to implement the chain rule and take the derivative of this, which is 1 over x. And at this point you could get the dy dx by itself, multiply both sides by y, so this is going to be y times, and I'm going to kind of consolidate things here, 2 over x times the natural log of x. And then what you have to do is you have to go back and you have to replace the y with what it was originally up here. So I'm going to take this and I'm going to plug it down in here for the y. So dy over dx is going to equal x times the natural log, x to the natural log of x times 2 over x times the natural log of x. And at this point you're really done. You can kind of simplify things a little bit, so you could rewrite this 2x to the natural log of x times the natural log of x all over x. And this is probably how you would find it on a multiple choice test or the answer in the back of the book. So here we go. Now I also want to show you what this looks like if you use the product rule. So if you use the product rule, you should get the same answer. So if we take the derivative of the left-hand side, you get 1 over y times dy dx. And then on the right-hand side, we have to do the first times the derivative of the second plus the second times the derivative of the first, and then simplify. So solve for dy dx. dy dx is going to equal, multiply both sides by y, so we get y times, and then these two are the same, so we have 2 of these, so we could just rewrite this 2 times the natural log of x, and I'm going to rewrite that over x. And then you want to replace again the y with what we have up here. And at this point, you've got exactly what's going on over here. So you would simplify the same way. So there are 2 ways to do this, but the first step that we implemented at the very top right here is the first thing we do is we write everything so that we don't have any exponents that contain variables. So and then what you want to do is differentiate. All right, I love this. I think it's so much fun. I hope you enjoyed it. I hope it makes sense.